All right, lesson 9.3 is titled Graph Data. So at the beginning of this chapter, I mentioned that it's all about data and graphs. So we're going to we've already looked at a couple graphs where we put some data into it, but this one's going to kind of explore how the coordinate grid can be used to display data. And we learned about the coordinate grid in lesson 2. So we're kind of taking both of those two first lessons and putting them together. So our essential question, our focus for this lesson is how can we use a coordinate grid to display data collected in an assignment? So data is often collected like in science experiments, right? So when someone, a class or a student or a scientist does some experiments or some exploration into a topic, they might collect some number data. And number data, when you have two sets of number or number pair related numbers, you can use a coordinate grid. So let's see how that works. Okay, so let's say that there is an experiment going on where some kids have a cup of water and they have a thermometer, and there's a thermometer measuring the temperature of that water to start. So at the very beginning of their experiment, they're going to measure the temperature of that water, and that's going to be their initial temperature. So for time, it's 0. The time is going to be, how long this experiment goes. So we've got 10 seconds into the experiment, 20 seconds into the experiment, and so on. But at the very beginning, at time 0, let's say they measure that temperature of the cup of water, and it's about room temperature, so it's about let's say 68 degrees. Okay, so it's 68 degrees at the very beginning, and then their experiment is to measure the temperature change when they add ice to that cup of water. So they didn't add ice yet. At the initial time of their experiment, they had to just take the temperature of the water at the beginning. But now they're going to add ice to that cup of water. And what do you think is going to happen to the temperatures? It's going to go down, right? Because ice makes the temperature cool, right? It makes it cooler and cooler. So let's say they add that ice and they start a timer, and then 10 seconds after adding ice, they take the temperature again, and now the temperature went down pretty good. It went down to 59 degrees. Okay. And then 20 seconds later, 10 seconds after the first 10 seconds, so we're 20 seconds into the experiment, they take that temperature reading again, and now they're at 53 degrees. Okay, and then 10 seconds more goes by, and they take the temperature of that water again, and they're at 49 degrees. Okay, and then they check the temperature again, and they're at 47 degrees. Okay, it's getting cooler and cooler because that ice is making that water very, very cool. Okay, 10 seconds go by and they take the temperature again, and now we're at 45 degrees. And then at the end of a whole minute, at the end of 60 seconds, they check the temperature again, and they are at 43 degrees. Okay, so here's our data. So this is data. How can we get this data to go into a coordinate grid, right? So remember, on our coordinate grid, we've got the x-axis along the bottom, and we've got the y-axis going up, and we've got number lines. Now this number line looks a little different because it's going by tens, and this number line is going by tens as well, but it's still a coordinate grid. Well, how can we do that? So we're going to have to figure out a way to get these numbers in our data to pair up, okay? And we're going to want our related pairs to be our ordered pairs. So we're not going to have 0 go with 47, because those are not related pairs. When it was time 0, the related pair for 0 was this number right here, 68. So it's kind of like we're going to basically take that pair of numbers right there, 0 and 68, and we're going to make this our ordered pair. Okay, so we're going to just take these pairs of numbers that we have in our data, and they're going to be our ordered pairs that we're going to put on our graph. So the first step is to write the related pairs of data as ordered pairs. So here's our first one. We're going to write 0, 68. That's our first ordered pair, 0 times 68 degrees. Our next ordered pair, we're going to use this couple right here. It's going to be 10, 59. Okay, then we're going to use this couple, the 20 and the 53, so 20, 53. And then we're just going to go down our graph. The next couple is 30, 49. And I'm just going to go up here, 30, 49. And then 40, 47. And then 50, 45. And then our last ordered pair is 60 and 43. All right, so now we have 7 ordered pairs using our data. And the last step is to graph them onto our coordinate grid. So remember from the last lesson, the first number is our x-axis and the second number is our y-axis, or our x-coordinate and our y-coordinate. So this means it's going to be over 0, up 68. So starting at origin, we're going to go over 0. That means we're not going to go over at all. And then we're going to go up to 68. Now, we got to kind of estimate here. So 68 is between 60 and 70 for sure, but it's a little closer to the 70. So I'm going to put it right here, like right underneath the 70. So there's my first one. Sometimes we like to kind of label. We don't have a point, like we don't have A's, B's, and C's to label the points, but I could just put that ordered pair right here, kind of small. So 0, 68 was this ordered pair right here. Okay, our next one, so I'm done with that one. I'm going to just kind of check off so I know I'm done. And the next one is 10, 59. So we're going to go over 10, up 59. So over 10, so starting at 0, over 10, up 59. 59 is going to be right underneath the 60. It's about right there. And then I'm going to label it 1059. Okay, check. The next one is 2053, so over 20, up 53, so it's going to be above the 50, about right there. 2053. Check. All right, and I'm just going to do these next ones a little faster. So over 30, up 49, over 30, up 49, check. Over 40, up 47, so over 40, up 47, it's going to be about right there, check. Over 50, up 45, 50, 45, check. And then over 60, up 43, 60, 43. All right, check. So there's all my ordered pairs, nice and graphed. And it's kind of nice seeing them in the graph because we can see that this temperature is indeed going down. We kind of noticed in the numbers they're getting smaller and smaller, but we can kind of see that trend in the graph of it kind of smoothly, taking that downward motion. All right, so that is graphing data using a coordinate grid. I've got one more example, I believe. One more? Yes. Ooh, I went through on my marker a little bit. Oops. Okay. Example 2, a mom is recording her son's height between the ages of 1 and 5 each year. So Billy's height, this is the title of our graph, of our data. So Billy's height. And this is his age in years. So when he's 1-year-old, 2-year-old, 3-year-old, 4-year-old, 5-year-old. And then his height is underneath. Okay, so when he was 1, he was 30 inches tall. When he was 2, he was 35 inches tall. When he was 3, he was 38 inches tall. Okay, so these are our numbers. We need to organize these numbers, or we need to figure out which ones are related and write those as ordered pairs. So we need to write the ordered pairs for these numbers so that we can put them in a graph. Okay, So which ones are related? And this is a little different. Our first graph, it went up and down, right? It had numbers side by side that were related. This graph goes side to side. So the ones that are related are actually the ones that, you know, are above and below each other, because it's when he was 1, he was 30 inches tall. When he was 2, he was 35 inches tall. So these are our related pairs. We're going to pair them up like this. Now to write that, we're going to have to decide which one's our x-coordinate and which one's our y-coordinate. I'm going to have the years, how old he is, be our x-coordinate, and the height be our y-coordinate. You could absolutely switch them around and have the x-coordinate be the height, but whichever one you decide, you want to make sure that in your graph you show that correctly. So I'm going to have the age be the x-coordinate. So 130 is going to be my first ordered pair, 1 comma 30. All right, and that's using this data set. The next pair is 235. So 2 comma 35 is my next ordered pair. The next one, 338, 338, and then 441. And then our last ordered pair is going to be 544. All right, so I took our data, I paired it up. They're related because it's when he was this age, he was this tall. So that's our related pair, and we can make them into ordered pairs. And we have 5 ordered pairs for 5 data pairs, so it works. Okay, the next thing we can do is we can graph it into a coordinate grid. All right, so I kind of started off our coordinate grid with the number lines, and I gave it a title this time. Since I had a title on my chart, it said Billy's height, I'm going to call my graph Billy's height. So there's the title of my graph. Okay, my x-axis, remember I decided that I want the age to be the x-axis. So my x-axis down here, I'm even labeling it age, years. Okay, because that's what it said up here, age in years. So I have age, years, and then I have 1, 2, 3, 4, 5, because those are the 5 ages that Billy's mom checked how tall he was, right? So this is my x-axis along the bottom. My y-axis going up the top, look at this. It's going all the way up to 50. I kind of needed it to go a little higher because my top number is 44, right? So I needed it to go pretty high. And then I should add a label over here. So remember, these numbers over here, they represent his height. So I'm going to put height. And then in parentheses, it's inches. I'm going to put IN for inches. Okay. And now I should be able to graph. So my first coordinate is 130. I'm going to go over 1, up 30. So starting at 0, over 1, up 30. About right there. Okay, my next one, 235. I'm going to go over 2, up 35. So over 2, up 35. 338. I'm going to go over 3, up 38. Over 3, up 38. It's a little under the 40, about right there. Okay. 441. I'm going to go over 4 and up 41. Over 4, up 41, a little bit above the 40. And then 544. So over 5, up 44. It's almost to 45. There we go. So there's Billy's height in a coordinate grid. All right. And then we can also answer questions with our grid. So here's a few questions that I have. So what does the ordered pair 338 tell us? Okay, well, we might want to look at that ordered pair and, you know, kind of decide, well, what was our x-coordinate? Our x-coordinate was the age, right? And our y-coordinate was his height. So 338 tells us that when Billy was 3 years old, he was 38 inches tall. That's exactly what it tells us. So 3 years old, 38 inches tall. And that's from the table up here. And that's also from our chart. Our x-axis was age and our y-axis was height. Okay. And our last question, why would the point 642 be nonsense? Okay, well, we know that 6 needs to be the age, right? So when he was 6 years old, our graph doesn't go to 6. I could definitely make this a little longer and have it be 6 over here. That's fine, okay? Because this arrow means it keeps going, right? So I could have a 6 over here, and then up to 42. 42 means he was 42 inches tall when he was 6. Why does that make no sense? Okay. Well, let's think about it. When he was 5, right? When he was 5, he was 44 inches tall. This point says that when he's 6, he was 42 inches tall. Now, do people usually shrink when they're 5-year-olds? No, they don't. Usually between the ages of 5 years old and 6 years old, they're going to grow some more. And this says that Billy went from 44 inches tall and he shrunk to 42 inches tall, and that makes absolutely no sense. So that is why it's nonsense, because this is a graph about Billy's height, and people do not get shorter between ages 5 and 6 usually. So that's why that point makes no sense. Okay, that is lesson 2. Go ahead and give the 9.2 form a try. I'm sorry, this is lesson 3. Go ahead and give the 9.3 form a try for some practice. Have a good day.